So, in the last class we are deriving the expression for omega s, that is hour angle. So, for horizontal surface the expression for hour angle is omega s is equal to cos inverse of in bracket minus 10 phi multiplied by 10 of delta. This expression was derived and we can calculate the day length here by using this expression. Okay. Since 15 degree is 1 hour, okay, we apply this knowledge to find out this day length, and for forenoon this omega s will be positive, and for afternoon this omega s will be negative. So, these conventions will be used for calculations of omega s. So, finally, we can have this day length T d we can express in terms of T d or maybe S max, which is equal to 2 by 15 into omega s. So, if we substitute the expression for omega s, this entire expressions, the entire expression will look like this. Okay. So, let us study what will happen in case of other surfaces. Say for inclined surface facing due south. So, as you understand, when we say due south, this gamma is equal to 0, that is surface azimuth angle is 0. So, the expression derived from horizontal surface will hold good for inclined surface facing due south if the representative day lies between September 22 to March 21 and the location is in northern hemisphere. So, if this condition is applies, then of course, we can use this expression for calculation of hour angle. And here in this case declination is negative. So, under this condition these expressions can be used for calculation of hour angle for inclined surface facing due south. The second case will be something like if the day, the representative day considered between March 21 to September 22, then we need to use this expression. So, these expressions can easily be derived by considering theta is 90 degree, substituting the original equations A, what we have understood that cos theta is a function of many angles. So, accordingly we can simplify the expressions and we can have this expression. Okay. So, here what happens, this declination is positive, and for this case as a whole, if we are interested to calculate omega s, then what we will do? We will do mode of omega s t is equal to minimum of both the expression this and this, then only minimum will be selected for the calculations. Okay. So, what we can summarize here, for inclined surface facing due south where gamma is 0, that is surface azimuth angle is 0, the under that condition straightway the expression which is whole good for horizontal surface we can apply straightway. So, omega s is equal to cos inverse of minus 10 phi and 10 delta if the day, the representative day lies between September 22 to 21, okay, and the location is in northern hemisphere. Okay. So, under that condition we can use these expressions. In the second case, if the representative day considered between March 21 to September 22, then we have to use this expression. Okay. And finally, of course, we will use the minimum of both the expressions for the calculation of omega s t. Okay. So, let us also learn something, one more surface called inclined surface facing due north. So, in this case what will happen, this omega st is equal to minimum of cos inverse of in bracket minus 10 phi multiplied by 10 of delta and cos inverse of in bracket minus 10 of phi plus beta here multiplied by 10 of delta. In earlier case it was phi minus beta. Okay. So, these expressions can all very easily derive from the original equation by considering cos theta is equal to 90 degree. Okay. So, let us take one example to understand. Say for example, if we take an example to calculate omega st for inclined surface facing due south. So, this is the case for due north. So, we would like to exercise one problem to understand the concept how this can be calculated. So, this WST we can write modulus. So, earlier expression, that is minimum of mod cos inverse minus 10 of phi, then we have 10 of delta. Okay. So, mod, then we have cos inverse of minus 10 of phi minus beta and 10 of delta. Okay. So, here if we take beta is say 10 degree, and if we consider the day, one may be June 21 and other may be we have say December 21. Okay. And if we know this June 21 and December 21, we can straightway calculate what is delta here for June 21. So, we can use the graph what we have discussed before. So, delta will be minus 23.45 degree, sorry, this will be positive, and for this case it will be minus 23.45 degree. Okay. Or also we can calculate the value of delta by using this equation 23.45, we have sine of 360 by 365 and 284 plus n. Okay. So, n value we need to calculate, because if we have to calculate for June, so n will be, so January is, if it is nonlinear, January is 31, then February will be 28 for non-leap year, then March will be 31, April may be 30, May again 31, and then June 1. So, if we add it, 8 plus 1 9, 1 10, then it is 2 12, 4 plus 3 7, then we have 7 plus 3 10, 12, okay, and then 15, 152. If we substitute these values, then we can calculate what is delta. So, we can use this expression for calculation of delta, otherwise we can use the plot what we have discussed before. And if we know these values, and also we need to know the location. If we consider locations having latitude is 19 degree 07 minute, okay. So, that can be converted into degree, 19 degree plus 07 divided by 60. So, this will be about 19.12 degree. Okay. So, this will be fine, right. So, now if we substitute this value of phi, then delta, okay, and beta in the expression, maybe here we can write A. So, A implies for the case 1, for case 1, that is on June 21. So, if we substitute the value, then we will get a value something like WST will be minimum if we substitute those values here, then based on the calculations we will get 98.6 degree and we will have 93.99 degree, which is equivalent to 94. Okay. Since we need to use minimum of these two expressions what we get, so finally our result will be 93.99, which is equivalent to 94 degree. Okay. So, this omega st, because it is modulus, it involves plus and minus. So, it will be plus minus 93.99 degree. Okay. And for if equation A for case 2, that is on December 21, omega st, which is modulus, what we will get based on the calculation, that is minimum of this minimum. So, if you substitute those values in expression A here, then what we will have, we will get 81.4 degree and then we will have 86.0 degree. Okay. So, what we will get finally, it is 81.4 degree. So, this will be plus minus if we say WST. Okay. So, plus is for forenoon and minus is for afternoon. Okay. So, this is the procedure how we need to calculate omega st for this kind of situation when inclined surface facing due south. Okay. And this variation is due to declination, as you can understand from this numerical exercise. So, if declination is varying, then our values of omega st is also varying. Okay. So, now let us discuss something on solar time. So, this solar time is very important, because when we need to calculate our angle, then we need to use this solar time. So, how to calculate this solar time is very important. Okay. So, what is this solar time? That is passage of time with reference to the position of sun in the sky. Okay. We take help of this clock time by using two correlations. The first correlation is the time difference between the longitude of a location and the meridian on which standard time is based. Okay. So, this is very important. First case, we should remember the time difference between the longitude of the location and the meridian on which standard time is based. So, every country, so standard time is based on certain meridian. So, that is fixed. Okay. And for your information, so correction has a magnitude of 4 minutes for every degree difference in longitude. So, this is very important. And the second correction is arises due to the length of the day. Okay. That is known as equation of time correction, is due to the fact that Earth's orbit and the rate of rotation are subjected to small variations, and the difference in minutes between the solar time and standard time. So, let us learn mathematically. So, this solar time or local apparent time is equal to standard time plus minus 4 into LST for standard, and it is LOC for the location, longitude of the location, plus this equation of time correction. Okay. So, when to use this plus sign and when to use minus sign? So, minus sign is for the eastern hemisphere. If the location is located in the eastern hemisphere, then we will use negative sign, and if the location considered is in western hemisphere, then we will consider positive sign. Okay. and this LST is the standard meridian for the local time zone. For India it is 81 degree 44 minute. So, we can convert it like 81 degree, and then if you have to convert it to degree again 44 by 60. Okay. So, this will be something like this. So, finally, it will be degree. So, we can remove this. Okay. And LOC is longitude of the location. So, that is known to us, and this E is the equation of time. So, this E equation of time can be calculated by using this equation. It is a long equation. So, if we substitute the value of B here, so how to calculate B? B is something like n minus 1 into 360 divided by 365. So, n is the nth day of the year. Okay. So, for example, if n is equal to 1, say for January 1, then what will be the value of B? It will be 1 minus 1 divided by 365 multiplied by 360. So, this will be equal to 0. Okay. So, under that condition, so cos 0 is 1. Okay. So, sin 0 is 0. So, okay, we can substitute here, and finally, we can calculate what will be the value of E on January 1. So, accordingly, you can use this for calculation of solar time. So, for example, if we have to find out this E value for February 1, okay, then what will be the value of n for February 1? So, its value will be 31. For January is 31 day plus 1, it will be 32. Then we have to substitute the value of n as 32, and then we can calculate B, and then we can substitute the value of B here in this equation, and then we can find out what is E. So, the value what we will get for E will be in minutes. Okay. If we are not liking to do the calculations, we can use this plot for calculation of this E value. Okay. So, this horizontal axis shows the number of days, and vertical axis shows this minutes or E value. Okay. So, on a particular day we need to choose this point, and then correspondingly we get the value of equation of time correction or E value. Okay. So, that way you can calculate. So, once we are done with this E, and we know these values LST and LOC, and we know the for which place we are doing the calculation, and if we know the standard time, then straight away you can calculate what is solar time. And also we can define one term called solar day. So, it is nothing but the duration between two consecutive solar noons is not exactly 24 hours. So, it should be hours, hours throughout the day. So, this variation is there, and this variation is taken care by this E. Okay. So, because of that we need to consider this E value. Okay. So, this is very, very important, because most of the cases or most of the time we need to calculate the value of omega, that is hour angle. So, if we have to calculate the hour angle, then of course, you need to calculate the solar time and local apparent time. Okay. So, in order to calculate this local apparent time, we need many parameters like standard time of that locations, then we have standard meridian for the local time zone, and then longitude of the location, and then E value or equation of time. Okay. And this can be calculated by using the equation here, or maybe we can use this plot. Okay. Also we have defined solar day. So, this variation is always there throughout the day. So, we need to take care of that. So, just for your information, we would like to list the difference between local time and standard time. So, meaning is like local time implies the time of a place determined on the basis of apparent movement of the sun, and standard time refers to the fixed time for places falling in the same meridian set in a country by law. Okay. So, that is important. And In case of local time, this changes continuously with change in longitude. Okay? And for standard time, it remains constant for a particular country. And for local time, the places on the same longitude have same local time. Okay? And for standard time, these places of the same longitude have different time zones. And finally, this is recon. Local time is estimated by shadow cast by the sun, and standard time is estimated by time zones. Okay? So, these are the differences between local time and solar time. So, these informations are required while classifying these two time scale. Also, we must know, see, for a particular month, if we have to calculate the radiation spectrum, then every day we need to calculate. Say for January, we need to calculate it for 31 days. So, what researchers have done, they have identified one day in a particular month which will represent the entire month. Okay? So, there are many recommendations like cleanse recommendations. Okay? People have done lot of studies. Based on the result of the studies, they have identified those important dates. So, for January, the researchers have identified 17th of January will give you the representative figure of the radiations or other calculations. Or February it is 16, then March it is again 16, April is 15, May is 15, June is 11. Okay? And then July is 17 again, August is 16, then we have September is 15, okay? And October is 15, November is 14, and December is 10. Okay? And also we can see how this n varies at the end of the year. So, n is 17 for January, then it is 47, then 17, then that way you can calculate. Okay? And declination variation is also shown here, how it varies. So, January 17 it is 20.9, then minus 13.0 for February, then minus 2.4 for March, and then you see 9.4 is for April, and is increasing and again decreasing. Okay? Because already you know the variation of delta with respect to the months. Okay? So, this value of delta is 0 for 2 equinox days. So, summer equinox and winter equinox. So, summer equinox will be on September 21 and winter equinox will be March 21. Okay? And is minimum on December 21 and is maximum on June 21, okay, which is equal to 23.45 degree. Okay. Now, let us solve one very interesting problem. So, this will give you a lot of understanding about what we have discussed so far as angles presence in a solar geometries are concerned. So, problem goes something like this: determine the angle of incidence of direct irradiance or solar irradiation on an inclined surface at 45 degree from the horizontal with orientation of 30 degree west of south, okay, and located at Mumbai. Latitude is given as 72 degree 49 minute east and 18 degree 54 minute north at 1:30 hours. Okay. This is 1:30 hours on December 15, 2019. Say the standard longitude for India is 81 degree 44 minute east. Okay. So, if we have to start this problem, then we will start with the data. So, solution goes something like this. So, here first let us identify the date n. So, what is the value of n here? N is on December 15, 2019. So, if we calculate the way I have shown, like 31, then 28 because it is a non-leap year month. So, it is 28. So, for leap year months it will be 29, and then you have 31, then we have 30, okay, that will go on. So, if we add it, then finally we will have n is equal to, so it will be 349. Okay. So, that I have calculated. Okay. So, once we know n, then we can calculate what is declination delta. Okay. Okay. So, declination angle is 23.45 is sine of 360 by 365. Okay. So, we will note this. Then we have 284 plus 349. Okay. So, this value we can calculate, and this is found to be minus 23.33 degree. Okay. So, declination we can find out here. Also we need phi. Okay. What is latitude? So, latitude is given as 72 degree 49 minute. Okay. So, then 72 degree plus 49 by 60, that will become degree, because we need to convert it to degree. Then this phi will be, as per my calculation, this phi is 18.9 degree. Okay. And the beta value is given as 45 degree, and it says that this surface is oriented at 30 degree west to the south. So, if we remember, so if we make a plot of something like this, okay, and this is north, this is south, this is east, this is west, okay, and this is west to the south. Okay. So, this angle, right. So, this is gamma, okay, this is gamma, and this is surface azimuth angle. This gamma is given as 30 degree. Okay. So, these values are given. So, now what we will do, we will calculate the value of theta. Before we calculate the value of theta, we need to calculate what is E value. So, once you know E, then we will calculate what is local apparent time. So, once we know local apparent time, then we will calculate what is omega. Okay. So, this way we will proceed, and finally, we will calculate what is theta. Okay. So, how we will calculate now? Let us see. So, delta, what we have calculated now, its value is minus 23.33 degree. Okay. And this E value we need to calculate, because n is known now. So, n value is 349. If we substitute here, then we will get a value of B, which is equal to 343.23, and if we substitute this B value here in here and here, and what we will get this E value, and each value as per my calculation, it is showing 4.9341 minutes. So, students can verify this result. And now we will calculate what is solar time. Already you know solar time is standard time. Okay. Standard time. We need to use minus sign here, because the place what we have considered is Mumbai, and this Mumbai is located in eastern hemisphere. Okay. So, this minus, then we have standard time longitude, then we have minus longitude of the location, then plus E. Okay. So, standard time is 13.31, 1:30 is the time, then 13:30 is the hours. I can write here. Then standard time longitude is we can go back. So, here, so standard longitude for India is 81 degree 44 minute. So, what we can write, it will be in 81 degree plus 44 by 60. So, if we do it, then it will be about 81.733. Okay. So, this is important. Okay. So, we got from here. So, if we substitute this value 81, we missed one term here 4. Okay. So, 4 multiplied by 81.733 minus 72.816. Okay. So, again we have E value already known to us 4.9341. So, this will be equal to 12.9926, and this is something like 12 hours. Then you have 59 minutes. Okay. So, since we know 1 hour is 15 degree, so from that we can calculate what is omega. So, omega will be 14.75 degree. Okay. Because as you can understand this omega, so this variation will be something like this. Okay. So, this part is positive and this is negative. So, this is about 12 hours. So, this is what, that is not 1 o'clock. Okay, here. So, if it is in 1 o'clock, then it will be 15 degree. So, this angle. So, this angle is 14.75 degree. Okay. Since this angle is in afternoon, so we will use the convention omega is minus 14.75 degree. Okay. So, now what we will do, we will substitute the value of omega in the original equations. Okay. This cos theta, this theta is a function of many angles. So, if you substitute all the values here, because all the values are known to us now, omega value is known to us, then beta is known to us. So, beta is 45 degree, then phi we have calculated 18.9 degree, then gamma is 30 degree, okay, and delta is minus 23.33 degree. Okay. So, these all values are known to us. If we substitute here, then we will get a value of something like 0.826258. Just we need to substitute the values, and finally, we can have theta is equal to 34.28 degree. Okay. So, this is a very interesting problem. So, it includes many components like how to calculate delta, how to calculate E, how to use this E for calculation of solar time or local apparent time, okay. And then finally, how this omega can be derived from this solar time, and then finally, we can use all the values given in the problem for calculation of theta. This theta is nothing but incidence angle. Okay. So, I will just recall what is theta. So, this is if sun ray is here, it makes an angle this theta. Okay. And if we start from here, maybe sunrise, so this will be your theta, or this theta is nothing but theta z. Okay. So, this is the incidence angle. Okay. So, this angle is 34.28 for this case. Okay. And this is the procedure we need to calculate the value of theta for this kind of situation. Okay. So, again let us solve one more problem. This problem goes something like, calculate the number of daylight hour, that is sunshine hour in Guwahati on January 2nd and July 2nd, and latitude of the Guwahati is given to you as 26.1 15 degree north. So, if our problem statement is something like this, then we can solve, say, for January 2nd, what will be the value of n? N will be 2, okay? And accordingly we can calculate what is delta, because already we know the expression for delta is 23.45, then sine of 360 by 365, 284 plus n, okay? So, if we substitute this the value of n is 2, then we can have delta value which is equal to minus 22.93 degree, okay? And for July 2nd, so n will be 183, so delta will be about 23.04 degree, okay? Since these delta values are known to us, and also phi is known, this is 26.15 degree north, okay? So, if we substitute these values in this expression, or S max is equal to 2 by 15, then we will have cos inverse, okay, minus 10 phi and 10 of delta. So, if we substitute the value of phi and delta here, then what we will have, that daylight hours, okay. So, this will be the daylight hours for January 2nd will be 10.40 hours, and for this case TD or S max will be 13.51 hours, okay. So, in this problem what we have discussed, how to calculate this day length on a particular day, okay. So, for January 2nd the value is found to be 10.4 hours, and for July 2nd this TD or daylight hours is found to be 13.51 hours, okay. So, this is the procedure how to calculate the day length on a particular day, okay, and particular place, right. Now, let us learn something about sun path diagram. The sun path diagrams are used to define the position of sun with respect to any geographical location on earth at a given day and given time throughout the year. And there are many applications. Out of the many applications, 3 primary applications are: number 1, optimum orientation of solar panels for installation. So, we need to maintain that optimum angle and orientation so that we can get maximum exposure to the solar radiation. And second point is very, very important for architect. They normally follow this sun path diagram for designing buildings to maintain thermal comfort. And the third concern is solar thermal energy devices installation planning by schedule determination. So, this is also one of the important aspects of this sun path diagram. So, this sun path diagrams determines the solar azimuth. Already you have learned what is solar azimuth and how this can be calculated, and solar altitude angles to study the position of sun from earth. So, now we are concerned about the position of sun from the earth, okay. So, how to identify the position of sun, okay. So, we will discuss how this can be done, and this solar azimuth and altitude angles are the functions of latitude, hour angle and declination. So, these are all are familiar with you now, what is latitude, what is hour angle, what is declination angle, right. So, this figure, if you see this figure very minutely, what you can understand. So, this is the north, this is south, this is east and west. So, sun will always move from east to west. Okay. So, there are 3 lines. So, if we consider a location in the northern hemisphere, and if we are interested for say winter, okay, so how this sun path will look like. Okay. For winter, this will move something like this, okay, and for summer it will move something like this, and in the solstice this movement will be something like this, where day length and same. So, here what my concern is, so this east west line is intersecting this east west line of this observer when sun path is on March 21 and September 21, otherwise it will deviate because of this declination. Okay. So, this is important, and already we have explained what are the different angles associated with them. Let us now see how this can be calculated, right. For different locations, we will have different this sun path diagram. Okay. So, for any arbitrary locations, if we consider and if we try to locate the sun's positions on a day at a particular time, that can be done. Okay. So, this scale outer periphery, this scale is for azimuth angle, and this scale, okay, this scale is for altitude angle, and here this is the month, okay, representing in the left hand side, and these are the months representing in the right hand side. Okay. So, January, February, March, April, May, June, and then July, August, September, October, November, December. Okay. So, these months which are placed in the left hand side, so these are representing by solid lines, and the months present in the right hand side, they are representing by dotted lines, blue lines. Okay. If I am interested to see the position of the sun on 1st April at 8 o'clock, then how to do it, and what are the angles like azimuth and altitude angle. So, what we will follow? We will follow this line, this solid line for this April 1st, and we will find out this point of intersection here, because these are the timings. Okay. So, this may be 6 o'clock, 7 o'clock, 8 o'clock, 9 o'clock. Okay. So, this 8 o'clock time is here, and this part moves and intersect here. Then what we will do? We will draw a line to the center of the circle, and we will extend it to the periphery here, and this scale will give you azimuth angle. And if we trace this circle and we will move on, and we will get a intersection point here. So, this is the scale. So, once we identify this scale, then we can get what is the altitude angle. Okay. So, by doing so, we can calculate altitude and azimuth angle. Okay. So, these variations like this pattern will be different for different locations. Okay. Let us see how it varies with different locations. So, this is Cartesian sun path diagram and then polar sun path diagram. So, this can be generated. So, what we have discussed is nothing but polar sun path diagram, and we can draw it in Cartesian coordinates also. See what happens. So, different sun path diagram can be seen if the location is varies. So, for example, if we consider Arctic circle, this variation will be something like this, and for Tropic of Cancer, the variation of sun path diagram will be something like this, and for equator it is somewhat symmetrical. Okay. And for Tropic of Capricorn, this will be something like this. So, the sun path diagram will be different for different locations. That is what we have shown here. Okay. So, this is very very important for designing and for solar equipment installation. Now, let us summarize what we have discussed in this lecture. So, primarily we have discussed all the angles required for calculation of solar geometry, okay, like what is declination, what is latitude, what is longitude, what is solar azimuth angle, what is altitude angle, what is surface azimuth angle, what is zenith angle, what is angle of incidence, what is slope. All the angles were studied and discussed, and also solar radiation geometry were discussed for horizontal and tilted surfaces. Local apparent time was discussed, and we have solved some problems to strengthen our understanding. Then sun path diagram is discussed, and also we solved numerical problems, which is very relevant for calculation of incidence angle or maybe solar time. Okay. And also we understand what is eastern hemisphere, what is western hemisphere, because sometimes we need to consider for eastern hemisphere, sometimes we need to consider for western hemisphere, and what is equator, and then how we have defined this phi. If we consider a place here, if we draw a line to the center of the earth, and if we project this line on the equatorial plane, okay, so this this angle will be phi. Okay, and there is the observer's meridian. So these aspects were discussed. Okay, so I hope that you have enjoyed this class, and this information should be required further for doing numerical exercise, and this will be applied for designing of solar equipment. Thank you for watching this video.